Did you know that nail polish was actually invented for men? It's true. It was invented for warriors back in the Babylonian days, going into wars. And these guys used different colors to differentiate between the different ranks in the army. So I may not be a warrior, but I'm a material scientist. And if you know me, you know that I work with resins, photocurable resins. And photocurable resins are basically just like nail polish. Therefore, today this nice company offered us a nice range of UV gel polishes, and they want us to analyze it. Therefore, I thought since we're going to be analyzing it using microscopy and UVVis spectrophotometry and many other techniques, why not do it together? Therefore, we're going to do it together. Come on.
3D alchemy.
That's enough for the music. Now let's start with microscopy. So we need the microscope because nail polishes have pigments inside. And these pigments need to be dispersed properly. And to check that out, we are going to prepare a suspension. And this is how we prepare a suspension. We start by adding a small amount of a solvent into a small glass vial. In this case, the solvent is acetone. And then we add a tiny amount of our nail polish. Just a drop. Once we do that, we need to stir it up a tiny bit to suspend these pigments in the solvent. Once the nail polish is well dispersed, we can add a small amount of it onto a microscope slide. We only need a tiny amount here, not much. And then we add a cover glass. We place the microscope slide under the objective of the microscope and we check. So first I adjust the focus knob on the microscope and here they are, the color pigments. If I focus a tiny bit more and I zoom in to, this is approximately 1000 times magnification now, you see these tiny specks. They are approximately 0.5 micrometer in diameter, very small, and they move around all the time because of Brownian motion, and that happens when the molecules of the surrounding matrix keep hitting these particles all the time and causing them to move around. Now if I take a sample of the pure nail polish, that is without diluting it, I place it on the microscope slide, I cover it with a cover glass, I push it just a tiny bit to make sure that it's well spread and kind of translucent for me to be able to see under the microscope. And when I see the sample under the microscope, I could see how densely packed that sample is with all these pigments, with all these organic, inorganic, and probably metallic particles. And if I zoom in, you could see how they look almost like a densely packed sea of particles. You have probably noticed that these color pigments look rather black or grayish in color under the microscope. While in real life, the sample we have is blue, and the nail polish we're analyzing is blue. And the reason for this is mainly the difference between transmitted light and reflected light. You see in this microscope, we have a light which originates from the base of the microscope and is then transmitted through the sample into the eyepiece of the microscope and then into our eyes. While in real life, whenever we deposit a small amount of this nail polish on our nails or onto a sample for that matter, what happens is that light gets reflected off the surface of that nail polish, and the specific wavelength of light which is reflected off the surface that hits our eye is then translated into color. Blue in this case. Did it get complicated? I think it's really simple. And to prove it, I'm gonna be running another test, which is called UVVis spectrophotometry. And it's so cool, but I have to take you with me to the other lab to show it. Let's go. Hey, remember to cover the microscope from the dust, yeah? It's very important. Now we're in the characterization lab, and this is a UVVis spectrophotometer. UVVis stands for ultraviolet and visible light. And this device here is called a UVVis spectrophotometer because it can generate a light source with a wavelength in the range of approximately 190 nanometers all the way to 1100 nanometers. And as you probably know, any light source with a wavelength between 190 nanometers and approximately 400 nanometers is considered UV light, and a light source between approximately 400 nanometers and approximately 700 nanometers is considered visible light, or any light we can see. In a typical UVVis measurement, the sample we have, whether it's a liquid or a solid, is placed between a light source and a detector. The light source is usually halogen or deuterium lamps, and it shines a light that hits the sample, penetrates through it, and lands on the detector. This light signal is then transformed by the detector from a light intensity into photocurrent. And when this happens, this photocurrent is taken from the device into the software, which then transforms it into a transmission or an absorption curve for us to analyze. The sample for this measurement is going to be prepared on a flexible mold. And here we're using this flexible silicon mold because it makes it much easier for us to detach the sample after we cure it. The size of the sample is going to be larger than the diameter of the sample holder. And to prepare the sample, we spread a thin layer of the nail polish onto the mold surface. We give it a few seconds to spread out, and we're ready to cure it. We put it in the curing chamber, and we leave it there for approximately 8 minutes under a blue light with a wavelength of approximately 405 nanometers. Now that our sample has fully solidified, we extract it from the mold, place it on the sample holder, make sure to fix it really well, and we put it in the spectrophotometer. The measurement is pretty fast, and the result, as you can see, showed that the sample absorbs almost everywhere in the spectrum, especially in the UV range that is below 400 nanometers approximately. And this is actually great news because whenever you place that nail polish layer on top of your nails, you're creating a barrier that protects the skin under your nails from both UVA and UVB. So it looks good and it protects you. Everyone is happy. If you like this video, remember to subscribe to the channel and share this video with someone you think uses a lot of nail polish. I think they would love you for it. They would too. They should.